Operation. Big word, but it simply means plus, minus, times. Don't have divide. Okay? Just plus, minus, and times. Here we have object translated from A to B. So it is simply called moving from A to B, translation. Then from B to C. So it went from A to B to C. The overall effect is to move from A straight away to C, right? If you have a choice to go from A to C, would you want to go from A to B then B to C, or you want to go straight to A to C? A to C lah, save some effort, right? We always try to find the shortest way. In this case, AC, the net, it is actually the net effect. It is the overall effect of AB plus BC. You agree with me? Right? We also learned that in our vectors. So we said that AB is the same as, AB plus BC is the same as AC. One thing for you to take note of over here. When you see vectors added up like this, pay attention. AB plus BC. We start, according to AB, this is our starting, start. Then this is our end, correct? Then what about for BC? This is our start. And then this is our end, correct? Then what do you notice about the ending of AB and the starting of BC? Ending of AB and starting of BC. Same, right? It's the same point B, isn't it? Okay. These two are the same. So I started from A, I go to B, then B I go to C. So effectively I'm going from A to C. So when this one, they are the same, then I can remove it, leaving me with AC. Okay? So if I have something very complicated, AB plus BC plus CD plus DE plus EF. Okay, what is the answer? What's the answer? AF. Get it? Because I went from A to B to C, D, E, finally F. So I add all of them up. It could have been like this. A to B, then B to C, D, E, maybe over here F. Effectively, after going so many rounds, it is the same as going from A straight away to F. This is my AF. Okay? That is addition. What do you mean number? You mean the magnitude? The overall, when you're talking about the magnitude of AF, it will be the same. If you're talking about the total distance traveled, then that is different already. But if you're talking about magnitude, it is AF's magnitude is simply AF. Okay? So resultant, we learned that in physics. Resultant force, when you have all the forces adding up, one force going upwards, one force going downwards, maybe this one 10 newtons, this one 3 newtons, then the overall is resultant 7 newtons upwards. Resultant, it's the same. Then we had left and right, maybe an object being pushed and pulled at the same time, maybe this one 3 newtons, this one 3 newtons, the resultant is? Resultant is 0 newtons. But we've been doing that for physics, very simple one, left, right, up, down. Have you been given this question before? This object is moved, pulled in this direction, 3 newtons, and then it is pulled this direction, 2 newtons. Find the resultant. Have you seen this in physics? Have or don't have? Don't have. Unless they ask you to do a scale drawing. We did that in lower sec before. So for this type of question, you are supposed to draw this. Remember? Then what do we do? After these two forces are drawn, you draw a parallelogram, remember? Zoom in. So this one is 3n. So you use your pencil, Then you draw this one over here like this, 3n. Then this one over here, 2n, right? 2n. And we say that this is our resultant. The black one is our resultant. So you take a ruler measure. And then you also have things like the angle. Correct? That is one way to do it. The other way is, this is called the parallelogram law of vector addition. The other way is simply to take these 2 Newton, right? These 2 Newtons at the bottom, I move it up over here. Just move the 2 Newtons up, then I'm starting over here, I'm ending over here. Still the same black line. You see it? The resultant is still the same. This method is called the triangle law of vector addition. So these are the 2 of them. Okay. So this one I mentioned before, the point B is the intermediate point. These are the same in your textbook. So we go from A directly to C for our resultant vector. I also mentioned in your lower sec physics, A, B and AD, the resultant is by drawing a parallelogram, and then the diagonal will give you the magnitude and the direction. And where's the triangle law? Okay, this one over here is our triangle law. You have 2 options to choose from. So example 8. Now this is where we see how it comes into play. I've got vectors A, B and C. These vectors, they have magnitude, they have direction. You cannot anyhow change them. Okay? Draw a diagram to find each of the following vectors and express it as a column vector. Now we start with vector A plus vector B. I prefer to do everything using triangle law. Okay? So I say I've got 2 options, triangle or parallelogram. I prefer to do everything in triangle. So A plus B. This is A. Starting from here, ending here. Now I need to plus a B. So all I need to do is just continue drawing B. What does B look like? B looks like this. This is the start, this is the end. I need to move 2 units to the left and 2 units down. So I go 2 units to the left, 1, 2, 1, 2. This will be my vector B. So the resultant is simply from here to here. This is my resultant. A plus B. Don't forget our worms. So as a column vector, what is it going to look like? Starting from here, this is my start. This is my end. I've got along the x-axis, to the left or to the right? Looking at the start position, am I going to the left or to the right? Left. By how many units? I'm moving to the left by 1 unit. Alternatively, you can say I'm moving -1 unit. Okay? So A plus B will be -1. Okay, 1 unit to the left. And how many units downwards? 1, 2, 3, 4, 5. -5. This is A plus B. Okay, Damira, do you understand? Do you understand or not? Don't understand because you're dozing already. If you're sleepy, wash your face or stand up. Not a punishment when I ask you to stand up. Okay? For those of you who missed it, let me try again. And then I want Q. So I'm going to draw over Q. Hey, I'm going to draw over Q. Then I'm going to select it. This Q over here. I'm going to put it over here. So now I have P plus Q. This is the whole idea lah. Okay? So effectively it starts from here and it ends over here. So P plus Q is equal to how many units left or right? Left or right? Am I moving left or right? No, right? So how many units would that be? 0. Okay? Then now, how many units up or down? 2 units down. -2. You can understand one. Go and watch the video again. Okay, this is the start, and this is the end. So let's do for R plus P. Okay, so R plus P. I've got R there already. Now I'm going to draw P. Okay, because I have a laptop, I can actually do this. R plus P. Okay, put it over here. Okay, they are the same thing, huh? So I am actually moving 1, 2, 3 units to the right and 3 units down. Okay, 3 units to the right and 3 units down. Same over here, 3 units to the right and 3 units down. So this is my starting. And this is my end. So effectively, I'm moving this way. And this is my resultant. This is R plus P. And this can be expressed as a column vector. How many units to the left or right? 2 units to the right. How many units up or down? -6. That's it. Understand? Okay, that's all. I'll continue during the next lesson.